Hi everyone, welcome to the Instructive Academy. So in the last video we had seen about the fundamentals of the periodic table, and today we are going to go a little more into the chapter studying about periods. So what are periods? The 7 horizontal rows of elements that are arranged in the increasing order of their atomic numbers are periods. So there are 7 periods. The period numbers, that is like 1, 2, 3 up to 7. What do they signify? They signify the number of electron shells of an atom. So for example, period 1 elements, for example, hydrogen has 1 shell. Period 2 elements, for example, lithium have 2 shells. And period 3 elements, that is, suppose sodium has 3 shells. This is all according to the atomic number. And period 7 will have 7 shells. So now there is something called as type of periods. This is a very small concept which is not that important, but it is good to know. So the period 1 is the shortest with 2 elements present. Then period 2 and 3 are again short, but they have 8 elements present. And period 4, 5, 6 and 7, they are called as the long periods. The period 4 has 18 elements, the period 5 has also 18 elements, period 6 has 32 elements, and period 7 has 26 elements. Coming to bridge elements. What are bridge elements? These are present in the period 2. They show similarities in properties diagonally with the period of the next group. So here I have given 2 periods and the group 1, 2, 13 and 14. So here what does it show? It shows similarity in property diagonally with the period of the next group. So lithium, so the properties of the lithium will be similar to that of magnesium. The properties of beryllium will be similar to that of aluminium. And likewise, the properties of boron will be similar to that of silicon. So, the elements in period 2 are called the bridge elements. Now, let's talk about the property trends of elements from left to right in a period. What does the first property say? The number of electron shells remains the same as we go from left to right in a period. Now for example, if we have these 3 elements, carbon, nitrogen and neon, with 6, 7 and 10 atomic numbers respectively. So here we observe that the number of shells remain the same as we go from left to right according to its electronic configurations mentioned here. So the next property says that the valence electrons, that is the electrons present in the last shell, they increase by 1. For example, if we take sodium, so by its electronic configuration, the electrons in the last shell is 1. Then if we take Mg, the electrons in the last shell is 2, aluminium 3 and silicon 4. And so on. The last property talks about the non-metallic character. It increases as we go left to right from a period. So therefore there is a transition from metallic to non-metallic characters. For example, if we take the period 3, we have sodium, which is the first element in period 3. So that's a metal. Then comes magnesium, even that's a metal. Aluminium is a metal. Silicon is a metalloid. Phosphorus is a non-metal, sulfur is a non-metal, chlorine is a non-metal, and argon is a noble gas. Now we come to the valencies of each element. What exactly do you mean by valency? The valency of an element is the measure of its combining power with other atoms when it forms chemical compounds. So if I go on explaining you in simple terms, valency is the number of electrons that a neutral atom of an element loses or gains in order to become stable. So for example, So here I have given a list of elements from period 2: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, with its respective electronic configurations and its valencies. Now you will exactly understand what I mean by valencies. So as I said, that valency was the number of electrons that the element loses or gains to attain a stable state. So for example, for any element to attain stability, the last shell of the element should have either 2 electrons or 8 electrons or 18 electrons or 32 electrons. In this case, if we take the element lithium, it has 1 electron present in the last orbit. So now, to attain stability, it will either gain 1 electron or lose 1 electron. Therefore, its valency is 1. If we come to beryllium, as an element it is stable already, but if beryllium wants to form a compound, it has to lose 2 electrons to attain stability, and that's why its valency is 3. Coming to boron, the valency of boron is 3. Why? Because now instead of gaining 5 electrons for the outermost orbit to be 8, it's better that it loses 3 electrons to become stable, and that's why its valency is 3. Coming to carbon, it can either lose 4 electrons or gain 4 electrons to attain stability. And when we come to neon, the valency of neon is 3. Why? Because now instead of losing 5 electrons, it is better that it gains 3 more electrons so that the outermost shell has 8 electrons, and therefore it can attain stability. And thus its valency is 3. Now coming to oxygen, the valency of oxygen is 2. Why? Because instead of losing 6 electrons, it's always better to gain 2 more electrons so that the outermost shell has 8 electrons present in that to become stable. Likewise, fluorine has a valency of 1. Why? Because it can attain 1 more. It can gain 1 more electron to become stable. And neon already has 8 electrons present in the outermost shell and does not require any losing or gaining of any electrons, and that's why the valency of neon is 0. The valencies of all the noble gases is 0 because it's stable. So I hope you got the concept of valency. Now we come to something called as electropositive character and electronegative character. Electropositive character, what does that say? It is the measure of the ability of the elements to donate electrons to form positive ions. Now this kind of property is seen in metals. So if we see the electropositive character increases from right to left in a period. Suppose we take the example of lithium. It's a metal with electronic configuration 2, 1. Now if lithium loses 1 electron, it becomes Li plus and forms a positive ion. The electronegative character is generally found in elements that can easily accept electrons to form negative ions. For example, the nonmetals. So, the electronegative character increases from left to right in a period. For example, if we take fluorine, it's a nonmetal, and what is its electronic configuration? 2, 8, 7. So now if the element accepts 1 electron, it attains the electronic configuration of a noble gas and it forms a negative ion, chlorine minus. So this was all about the periods of the periodic table, and stay tuned for the next video on groups of the periodic table. And if you like this video, do turn the black thumb blue and go subscribe to it. Thank you.